So hopefully for problem 9, it says 3 circles are externally tangent to each other and internally tangent to one larger circle. So hopefully you knew what externally tangent and internally tangent were. If you didn't, ask, because we would have told you that. These are definitions. So externally tangent means that they are tangent at a place not inside. So basically they're outside of each other, right? And then internally tangent means essentially one of the circles are inside the other circle. So when it says 3 circles are externally tangent to each other, there's actually only one possibility, because each circle has to be internally tangent to every other circle. The only way that you can do this is if you have this kind of shape. Right? So then the question is, given that you know that it's in this shape, right? How would you be able to figure out the entire radius? Recall that the radius, it's given in the question, is 3 units. So one thing that you might notice is by symmetry, right? The center of these 3 points will be the center of the circle. This is, again, by symmetry. Like if you thought about it, if it was anywhere else, then it would be asymmetric, which wouldn't make sense. So you can pretty confidently say that the center of this triangle, right, made by these radii, is the center of this entire circle. And what you're trying to figure out is the radii of the entire larger circle. So it would look like this. Right? Because it's fair that this point is a point on the larger circle, right? And the radii is just the length from the center to a point on the boundary, which is the larger circle. So the question is, how do you figure it out? Well, you know this length. This length is just 3. So then what is this length then? Well, we use the 30, 60, 90 triangle thing again. So, well, first thing is since we already went through the proof, I'm not going to belabor it too much, but you might remember that it's in a ratio of 1 to square root of 3 to 3, or to 2, sorry. So if this is 6, because 3 plus 3 is 6, then this length, this entire height, should be, yeah, you're right. It would, like, the ratio would be something like this. So this entire length should be 3 root 3. But do you remember from like problem 5 or problem 6, we showed that this length, this entire height, is 3 times this shorter length? You remember that from problem 6? So like if this was A, then 3 root 3 should be equal to 3A. This length, right here, right? So that's what we showed in problem 6. And like how do we prove that again? You drop the altitude here. You remember that this length has to be the same length as this. And then by, again, 30, 60, 90, the hypotenuse is 2 times the length of this. So this should just be 2a. And what is a? A is equal to root 3. So this length should be 2 root 3. And then this entire radius, so this large radius here, I'll call it R, is 2 root 3 plus. Does anyone have any questions with that one? Is that too fast? Did I go slower? Is that all right?